All right. Still continuing with section 4 with those double angle identities. Let's do some more examples with them. This example says express cosine of 3x in terms of cosine of x alone. So we're going to start with cosine of 3x and we're going to manipulate it using our identities over and over again until we get only in terms of cosine of x. Keep in mind, 3x is 3 times the angle. So it's like, if we're talking about cosine of 30 degrees, cosine of 3 times 30 degrees, right? 3 times 3, so that's cosine of 90 degrees. So they're wanting you to write what cosine of 90 degrees is in terms of cosine of 30 degrees, but in general, right? So keep in mind, my point is that we're talking about two different angles here. All right, so we're going to start with cosine of 3x, and we're going to use the composite angle identities first, right? So cosine of 3x I know is cosine of 2x plus 1x. That's equivalent. All right. And then we'll use the composite angle identity that says cosine of one angle plus another angle is cosine, cosine, sine, sine. Change the sign in the middle. So it's cosine of the first times cosine of the second. Change the sign in the middle. Sine of the first and sine of the second. Okay. So that's looking good. Cosine of x is looking good. The sines are not looking good, and neither is the cosine of 2x looking good. So we need to do more with this. But cosine of 2x, we have a double angle identity for that. And there's 3 of them to choose from, right? But since I want everything in terms of cosine and only cosine, then I'm going to choose the identity that has only cosine in it, which is 2 cosine squared minus 1. And then I've got it's still times cosine. And then sine of 2x, it's in sine. I need it in cosine. Can't do anything about that yet, but I can at least get it into the correct angle. So 2x, I need it in terms of x, not 2x. And so we have an identity for that. That's 2 times sine of x times cosine of x. And then I still have times sine of x. Okay. Well, let's distribute this cosine into both of these terms. So this would be a 2 cosine squared times cosine, gives you a 2 cosine cubed. And then a minus 1 times cosine would be a minus cosine. You have a minus. There's no plus or minus signs here. They're all multiplied. So it would be a 2 sine squared, because sine times sine is sine squared, times cosine of x. Okay, we are so close, right? Because this one, I know that it's a cubed, so when it says cosine alone, then it's okay to have cosine squared and cosine cubed, because in reality, it's cosine of x quantity squared and cosine of x quantity cubed. So those are okay. Not okay to have cosine of 2 times x, because that's like talking about 60 degrees instead of 30 degrees, right? But all of these, this is cosine of 30 degrees and then cubed. It's still in terms of cosine of 30 degrees. So those are okay. So that one's good. That one's good. This cosine's good. This sine squared is not. But we have an identity for that. The Pythagorean identity says sine squared plus cosine squared is 1. So rearranging it means that I can rewrite that in terms of, I have a 2 times, instead of sine squared, I'm using Pythagorean identity that says it's 1 minus cosine squared. And then I still have a times cosine of x. I guess I should have attached the 2 over there. Oh well. Okay, so now we're going to distribute into the 1 and into the cosine. So I've got 2 cosine cubed minus cosine still. And then I've got a minus 2 times 1 times cosine, so that becomes a minus 2 cosine of x. And then distributing times the cosine squared, it's a cosine times a negative cosine squared times a negative 2. So it ends up being a positive 2 cosine cubed. Okay, so now everything is in terms of cosine of x. I just need to combine them like terms and simplify this. 2 cosine cubed plus 2 cosine cubed gives me a 4 cosine cubed. And a minus cosine and a minus 2 cosine gives me a minus 3 cosine of x. There you go. Everything is in terms of cosine of x. I know there's a cube on it, but that's okay. You can think of it as if you're writing in terms of x and there was an x cubed, no big deal. It's still in terms of x. Okay, let's do another one. Let's express sine of 6x in terms of sine of 3x and cosine of 3x. Okay, so notice over here, 3x, I had to use the composite angle identities, right? But for sine of 6x, 6x is exactly twice as big as 3x. Yeah, so you can use the double angle identities. So when exactly twice the angle, use the double angle identities. So sine of 6x is equal to sine of 2 times 3x. Oh, nice. All right, so this is your angle. It's like sine of 2 theta. This is your theta. That's equal to, using the double angle identity for sine, 2 times sine of the angle, which is 3x, times cosine of the angle. There you go. You're done. Easy peasy lemon squeezy, right? All right, how about one more? Let's express cosine of 10x in terms of sine of 5x alone. Okay. Well, I noticed the same thing, right? That 10x is twice the size of 5x. So cosine of 10x is equal to cosine of 2 times 5x. Yeah. Now, we have 3 double angle identities for cosine, right? We've got that cosine of 2 theta is cosine squared minus sine squared. That was one of them. We have 1 minus 2 sine squared, and we had 2 cosine squared minus 1. That was from day one's lesson, right? The double angle identities. So for cosine of 2 times an angle, you've got 3 of them to choose from. They want you to write it in terms of sine alone. So this one has a cosine and a sine. This one only has cosine. We're going to use the middle identity to replace this with. So this is equal to 1 minus 2 times sine squared of 5x. You're done. When it says 5x alone, of course you can have a 1 added or a subtracted or whatever, It's just that they didn't want you to also have cosine in there also. So, okay. So that's how you handle those ones. Just rewriting, using the identities. Let's do this one. Let's find the exact value of cosine of 2 times arc sine of 1/3. Yeesh, right? Okay, so here's how you're going to do it. You are going to let arc sine of 1/3 be your theta. Yeah, so that means if theta is arc sine of 1/3, this means the same thing as sine of theta is equal to 1/3. Yeah, So now, if I know sine of theta is 1/3, I know information about this angle, right? I know it's positive, so it's got to be in quadrant 1 because it said arc sine. Arc sine is either in quadrant 1 or quadrant 4. This is y over r, so y is 1, r is 3. And then to find the x value, you got to use Pythagorean theorem. X squared plus 1 squared is equal to 3 squared. Yeah? So that you get, this is x squared would be 9 minus 1, so 8. So x is equal to technically plus or minus rad 8, which is 2 rad 2. I'm going to choose the plus sign though because I'm in quadrant 1. So 2 rad 2. Okay, so that's all the information I need for theta, right? Okay, so since I let this be theta, then what I'm asking you for is, what I want is cosine of 2 theta. Yeah, and you've got 3 identities. You can choose any of them. It really doesn't matter which. But since they gave me sine, let's just do sine, the sine one, which was 1 minus 2 sine squared. Yeah, well, sine was 1/3, which means technically I didn't even need to find all this information out, right? But just in case, because there will be ones where you will have to. Yeah, especially if I had asked you for sine of 2 theta, you need both sine and cosine for that to happen. Okay, so, but here, they're only asking for this, so this is 1 minus 2 times sine of theta squared. Sine of theta is 1/3, so we plug that in. And then that's a 1 minus 2 times 1/3 squared is 1 times 1 and 3 times 3. So that means this is 1 minus 2 over 9. To subtract these, you need a 9 over 9 minus 2 over 9, which is 7 over 9. Do, 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 do. Not too bad. No? Hopefully. All right. How about, let's find the exact value of sine of 2 arc cotangent of 2/3. By the way, back up to this one. Since I knew, I found sine of theta is that, right? But and now I also have cosine. So I also could have done cosine squared minus sine squared, and you'll get the same value. I'll show you that real quick. If I had done cosine squared minus sine squared, you should still get 7 over 9. Cosine would be a 2 rad 2 over 3 squared minus 1/3 squared. 2 rad 2 squared is 8. 3 squared is 9. Minus 1 over 9 gives you a 7 over 9. So same answer, right? You also could have done 2 cosine squared minus 1, which is the third identity for cosine of the double angle. Any of them work. They will give you the same answer. Yeah. All right, so we're going to do the same thing here that we did up there, where I'm going to let arc cotangent of 2/3 be theta. So if theta is equal to arc cotangent of 2/3, which that's the same as inverse cotangent, right? So that means cotangent of theta is 2 over 3. What does that mean? Well, cotangent is x over y. So they gave me my x and my y value. It's positive, so it's definitely in quadrant 1, where your x is 2 and your y is 3. R will be 2 squared plus 3 squared. So r will be plus or minus the square root of 4 plus 9 is 13. So this is, and r is always positive, so boop, choose the positive guy. R is never negative. It's the distance. So, okay. So now that I've got that, what I'm asking, what this is asking for is sine of 2 theta, okay, where this is my theta. All right, well, sine of 2 theta is 2 times sine of theta times cosine of theta. Those were the identities you were given yesterday. Well, for this triangle, this is theta. Your sine of theta would be y over r. So that's a 3 over rad 13. And cosine of theta is x over r. So 2 over rad 13. And I know technically I'm supposed to rationalize and all that, but I'm going to be multiplying these guys together, so don't bother, right? We got a 2 times 3 times 2 would be 12. And rad 13 times rad 13 is 13. See? I know technically you're supposed to rationalize, but it's easier if you don't when you're going to be multiplying them anyway. All right, let's do another one. Okay, this one's going to be fun. Let's find the exact value of cosine of inverse secant of 3/2 minus inverse cosine of 1 over 5. Okay, holy macaroni. All right, I'm not going to use theta this time because I have two different angles. These are talking about two different angles. I'm going to let this guy be A, and I'm going to let this one be B. Yeah? So then that means if A is inverse secant of 3/2, that means secant of angle A is 3 over 2. Over here, if B is inverse cosine of 1 over 5, that means cosine of angle B is 1 over 5. Yeah? So I can draw the triangles for A and B. So for A, they're both positive, so they're both in quadrant 1. Secant is the reciprocal of cosine, so that means this is r over x. So your r is 3, your x is 2. And when you do Pythagorean theorem, 3 squared equals 2 squared plus this guy squared, you end up with a rad 5 for your y, doing Pythag, right? 3 squared is equal to 2 squared plus y squared. 9 minus 4 is 5 is equal to y squared, and so your y is rad 5. Over here, because it's also positive, so quadrant 1, and this is x over r, so x is 1, and r is 5, and so that's a 5 squared is equal to 1 squared plus y squared. 25 minus 1 would be 24 is y squared. Taking the square root of that, there's a perfect square in there. 24 is 4 times 6, so this is a 2 rad 6 is going to be your y value. Okay, so this is angle B, and this is angle A. Okay, now I rewrote this as I let this be A and this be B, so what I'm wanting is cosine of A minus B. Well, that's a composite angle identity. You know this. Cosine, cosine, sine, sine. Change the sign in the middle. Cosine of A times cosine of B. Change the sign. There was a minus sign here, so I'm changing that one to a plus. Sine of A times sine of B. But I've got all these values right here. I got my triangles. All right, so cosine of A would be x over r, so that's 2/3. Sine of A would be y over r, so rad 5 over 3. I just went and plugged in the A angle first, right? Cosine of B, this is B, would be x over r, so 1 over 5. And sine of B would be y over r, so 2 rad 6 over 5. Yeah? So this becomes a 2 over 15, because you go 2 times 1 and 3 times 5, plus rad 5 times 2 rad 6, which is a 2 rad 30 over 15. 30 is 5 times 6, and 6 is just 2 times 3, so there's not a perfect square in 30. And then your final answer would be 2 plus 2 rad 30 over 15. The 2's don't go into 15, so there's no canceling or anything no simplifying that can happen there. Okay, let's do one more. I know it's making a little bit of a longer lesson, but I'd rather you see a bunch of examples rather than completely struggle with the homework. How about sine of inverse cosecant of -5? Yeah. All right. So I'm going to let all of this inside here be theta, which means your theta is equal to inverse cosecant of -5, which means cosecant is equal to -5, and cosecant is the reciprocal of sine. So that means this is like over 1. So this is a r over y. Okay. So drawing that triangle, inverse cosecant. Ooh, it's negative this time. Okay, is it a banana or a rainbow? Well, it's a banana. Hopefully you remember that. If it's negative, you're going to go into the negative direction here. This is r over y, so r is 5 and y is 1, but I got a negative there. Which one do I put it on? Your r is never negative. It's always going to go on the y. Yeah, so that's a -1. And we just want sine. Well, okay, so you could find it, right? You could find the x, but honestly, it's not necessary. It's equal to x squared plus -1 squared. So that's 25 minus 1 is 24. And so x is, where do we figure that out? 2 rad 6 again. Okay. And so what's sine of this guy? So I found the x value, but in reality, I didn't even need it because what you're wanting is sine of theta, which that's y over r, -1 over 5, because it's y over r. Yeah. All right. There you go. Not too bad, right? I know it's not fun. All right. Well, you guys have a fabulous day.